Hi there, welcome to another Maths School video where today we're going to be looking at probability, relative frequency and estimating things and events. Alright, so let's have a go. So we're going to start off with probability. Now, in most cases the probability of something happening is often deemed as a fraction, or something out of something else, or a percentage. So there's a 50% chance happening, or sometimes as a decimal. It can be either of those three things, simply because they all need to be less than 1. All right, the chances obviously something happen have to be less than 100% or less than 1. And if you're not quite sure what I mean by the fractions and decimals and percentages, well, they can be easily converted between each other. If you're not quite sure about that, please look at the video about converting fractions, decimals and percentages. But it can be any of those three things in terms of probability, but it tends to be given as a fraction simply because we're talking about something out of something else in an awful lot of cases, and it's just not, when the numbers are a little bit more awkward, it's much easier to leave it as a fraction. All right, but we'll talk about that as we go through. All right, so in essence, probability of an event, there are a number of times that the event occurs, divided by the total number of possible outcomes. And as you can probably see from those two things there, is that the number of times something event occurs divided by the total number of possibles. Well, the number at the top can't be bigger than the number at the bottom. Hence, it has to be less than 1, and hence it tends to be a fraction, which of course could be a percent, but we're going to leave things as fractions for the purposes of today. All right, so let's look at examples. Examples are the best way of looking at this. So throw a fair dice. What is the probability you roll a 3? All right, so we've got to look at the number of times that possible event occurs, thinking about what it said at the top here, and the number of times the event occurs. Well, there's only one way you can get a 3, all right, and that's a 3, all right. But the total number of possible outcomes, of course, is 6. There's 6 numbers on a dice. So in terms of the probability of getting a 3, there is only one of them on there, and there are 6 numbers on the dice, so the probability of being 1 out of 6. And again, leaving it as a fraction. That would be quite difficult, unless you know it, of course, you might know it, and what that is as a fraction, sorry, as a decimal or as a percent. All right, so we can just leave it as a fraction. All right. What about an even number? Well, an even number, let's think about it in context. Well, how many even numbers are there on a dice? Well, I think I know my even numbers on a dice. You've got 2, 4 and 6. Is that right? Yep, there's 3 of them. All right, so there are 3 things, 3 outcomes out of how many in total? Well, there are 3 out of the possible 6 which are even. All right, so leaving that as a probability, it's going to be 3 out of 6, 3 over 6. Now, the temptation, of course, with probability, and especially when you're looking at a fraction, is do you decide to simplify it or not? All right. Well, with probability, you don't necessarily need to simplify it, and you would not lose marks if you did not simplify it. All right. I'll say that one more time, just in case you thought you may be misheard. You will not lose marks if you don't simplify a probability. You may lose marks if you're asked to simplify your answer of another question which involves a fraction. All right, so just be aware of those two things. All right, for the sake of obviously avoiding error or mistake, if you can simplify it, then please do. If you're unsure or you're not confident with the simplifying, then again, please look at a previous lesson and try and look at the simplifying fractions and get on top of it. But if it's probability, I say it one more time, you don't need to simplify it. 3 out of 6 would get you the mark. Okay. So let's look at another example. A bit more visual, this one. So you pick a shape at random, and what's the probability? I pick a triangle. All right. So what we're not told is how many shapes there are or anything like that. So we need to figure out that. And how many triangles there are. Well, I can only see one triangle, as mine's not deceiving me, and that's the green one over here. Where is it? There, the green one there. And how many are there in total? 1, 2, 3, 4, 5, 6, 7, 8. So there's 1 out of 8, if I'm not mistaken. Hopefully they agree with me. Yeah, one triangle, 8 shapes, probability 1 out of 8. All right. What about a circle? All right, well, let's have a look. There's 1, 2, 3, 4. There's still 8 shapes, so the denominator is not going to change. So like before, I've got 4 over 8. And of course, the temptation, we might as well. That's an easy one to simplify. Let's cut it a half. All right. So either of those two answers at the bottom will give you the mark. All right. So either of those two. All right. So that's probably of an end. All right. So you've got to read the question carefully, but it's quite a simple kind of process. In how many ways can you get it out of how many possible outcomes are there? All right. It says at the bottom, don't forget to simplify, but like I kind of mentioned, with probability specifically, this is more about you practicing simplifying fractions than actually getting the marks in the GCSE With probability, you don't necessarily need to simplify it. Right, relative frequency. It's similar to probability, very, very similar. But this is based on a trial of something happening. All right, with the dice, we know there are 6 outcomes, and it tends to be that that's what you're going to get. But the relative frequency is an estimate of the probability of events. We don't know what the probability is. We're going to use it based on a trial of events. All right, it's sometimes called experimental probability. All right, so this is where we don't really know if the probability is a fact. So we do a trial, and we use that trial to determine what we call relative frequency as opposed to actual probability. So you can use results from experiments to estimate the probability. As you increase the number of trials, the probability becomes more accurate. So the more trials you do, the more accurate it becomes. So an example in relation to that, if I were going to roll the dice 1 million times, you would expect a sixth of them to be the number 1. If I was going to do it 6 million times, again, you would expect a sixth of them to be number 1. However, if I only did it 4 times, you're not going to expect a sixth of them to be a 1. You might not even get a 1. So clearly, the more and more and more that you do, the more accurate the probability that you are likely to get. All right. So relative frequency, a little bit like probability, it's the number of times the event occurs over the number of trials. So that the bit at the bottom is a little bit different because it's about the number of trials it actually completed. Okay. So again, if I were to roll the dice 4 times and I got no 6s, then the relative frequency would be none out of 4. All right. We know that that's not actually true. It's not the probability, but in terms of the relative frequency, I have to take it as read. There's no chance of getting a 6 because in my trials I didn't get one. All right. So they are slightly different. So here we go. Here's your example for you. So Tom rolls a biased dice 100 times and gets 4 7s. So gets a 4 7 times. All right. So he got 4 7 times. What is the relative frequency? Well, the relative frequency of getting a 4. Well, he only got 7 of them out of 100. So it's 7 out of 100. All right. He rolls the dice another 100 times and gets 3 more 4s. What is the new relative frequency? Now, this is where we've got to be careful, because the temptation here would be to say 3 out of 100. But of course, it's not the case, because what we've done is we've rolled the dice 100 times more. So now we've rolled it in total 200 times. Well, how many I've got out of all the 200? Well, I had my 7 here, and I've got my 3 here. So that's 10, isn't it? And it's 10 out of how many rolls now? Well, it's 200 rolls now. All right, so relative frequency is 10 out of 200. And what do you reckon? Well, do I leave it like that? Well, of course I can, but of course it does simplify to 1 out of 20, so I should simplify it if I can. So which estimate is the most accurate? Well, this is the bit I was talking about right at the beginning of the lesson. The more and more and more and more that you do, the one that's most accurate is the one that's had the most trials. All right, so the one at the bottom has had the most trials, so that it would be my most accurate. All right. Right, the final one, a part of this probability is estimating. So it's about you guessing how many you would expect to get. All right. So if I go back to the dice idea, if I was going to roll a dice 600 times, I use 600 for a reason, then I would expect a sixth of them, because the chances of getting any number would be a sixth. So the chance of getting a 6 on a dice, if I roll it 600 times, I would expect around about 100. But it's kind of putting that down and understanding that is what we're looking at today. So you can use the probability to estimate how many times the event should occur, or not necessarily will occur, but should occur. So the number of times the event occurs equals the probability times the number of trials. All right. So thinking about what I just kind of said. So Liz rolls a fair dice 300 times. She estimates how many times she rolls a 3. Well, the chance of getting a 3, a bit like I had a minute ago with a 6, is 1 out of 6. There's only one number on the dice, so the chances of 1 out of 6. So she would expect the number of times the event occurs, so the number of times the event occurs, to be the probability, so 1 out of 6, 1/6 times 300 in this case. All right. So 1/6 times 300, which is the same as a sixth of 300, which is 50. All right. So that's what she would expect. You not necessarily would get that, because obviously we don't know, but again, that's her estimate, and it's a reasonable estimate. So what about this one then? So Fracty tested 100 laptops and 3 were faulty. So I estimate how many faulty laptops there would be if they tested 840. So what we're looking at here is kind of the idea of thinking, well, based on a initial assessment, 3 out of every 100. All right, so we wouldn't call that a probability, we'd call that a relative frequency, wouldn't we? So we're going to do a relative frequency of what she got and times that by 840. All right, so we're going to do 3 out of 100, all right, times by 840. So this terminology here, you need to be a bit careful with. We're just in terms of probability, because this one was about probability, is what she'd expect, and this one here is based on a relative frequency idea, isn't it? This is what we've got, and taking that as would continue with for the rest is how many I would expect for the rest. All right, so going back to this, it's 3 out of 100 times by 840. So relative frequency equals 3 out of 100, or 0.03, or we've gone for decimals, and it times that by 840, which gives us 25.2. Well, we're not going to get 25.2 faults, so we need to round it to the nearest whole number, really, so 25, and again, it is just an estimate anyway. Okay, so that's the end of that. Hopefully that kind of makes sense. If you need obviously more practice on that, like I've said with many other videos, please go to the website, mathsivenschool.co.uk. It's free to access, like most of kind of resources to look at the videos, but again, please like and share the video clicking down below. Cheers then.